I'm Anil Kumar. Welcome to my series on statistics. In this video, we are going to study how do we analyze a group data. From the group data, we are going to draw cumulative frequency polygon and then find quartiles. We are also going to derive a formula to find the median and then verify our results using the given formula. Well, the formula is given before you. The median can be written as or calculated with the help of the formula given here. So we'll discuss this in the video. Let's look into the data first and then see exactly how do we work when we are given a grouped data. The question here is, the table shows length of Atlantic salmon caught by Amy. We are given the length in the interval 60 to 62.5, frequency. The number of fish in this interval was 2, then 62.5 to 65, 8, 65 to 67.5, 15, 67.5 to 70, 33, 70 to 72.5, 19, 72.5 to 75, 3. So that is the data which is given to us. Now, from this data, what are we going to find? Well, first describe what is a cumulative frequency plot, also known as ogive. Then we are going to draw the cumulative frequency diagram. Now, cumulative frequency plot is given different names. We call it a cumulative frequency graph or a polygon also. Now, from the graph, we are going to estimate the median length of fish. We'll estimate the lower and the upper quartiles. The lower quartile is Q1, the upper one is Q3, first or third. We'll find the interquartile range. We'll answer questions like estimate the 90th percentile. Now, before we get into the details, let's try to understand the grouping of this data also. When we say the interval from 60 to 62.5, it really means that we are taking the length of the fish, which is greater than or equal to 60, but less than 62.5. So if the length is 62.5, it will be considered in the next interval, which is from 62.5 to 65, right? So I hope this concept is clear to you. Now also, to draw a cumulative frequency diagram, we have two different methods. So the default method for the cumulative frequency diagram is known as the less than method. When we say less than method, we're trying to say here that there are two fish which are less than 62.5. When we add 2 and 8, we get 10. So how many fish are less than 65? 10. So that is the less than method. So when you use less than method, in that case, we are working with upper bound. So when we make cumulative frequency diagram, in that case, we are always working with the upper bound when using a less than criteria, right? So globally, different standards are adopted. So you should check with your teacher what is being actually expected from you. Let's continue with this question and understand how do we actually plot a cumulative frequency diagram. So once again, the table provides us with the data. So we have the intervals 60 to 62.5 means an interval over the length of 2.5, and within this interval we have two fish. So that is the length of two fish. Let's see how do we find the cumulative frequency. Cumulative frequency is the running total, right? So when you say cumulative frequency, I'm writing in short. It basically means the running total. So, so we have 2 in the given interval. The next one will be you add 2 to 8 and then you get 10. So keep on adding. So once you add the next one, you get 25. It really means that, let me write down here. What does it mean? It means that length of fish less than, let us say, less than 65 is what? Less than 65 is 10. You understand? That is what it means. So that gives us a coordinate value to plot on the frequency diagram. Perfect. So when we draw a cumulative frequency diagram, in that case, on the y-axis, we have the cumulative frequency. And on the x-axis, we have the upper bound of interval. So that is very important to understand. So the value, the first one itself, which is 60 to 62.5, we have 2. So that gives us a coordinate value of 62.52, right? The second one, less than 65, we have 10. So 65, 10. Less than 67.5, when you add, you get 25. So that gives you the third coordinate point. Likewise, when you keep on adding, then we get these coordinates 72, 58. 72.5 is 77, and when you add all of them, then less than 75, we have 80. So that is the final point. Joining these points, we'll get a graph which will be kind of like this. Now, critical point here is missing. That critical point which I want to highlight is what is the point where the graph should start from. Now, that is the starting point, right? So we have to check the starting point, which is right on the x-intercept. So the data also tells you how many are less than 60? None, right? So 60 is 0 is the starting point. So we know that less than 62.5 are 2. How many are less than 60? Well, none, right? So think like this. So that gives you the starting point, which is 60, 0. So whenever you draw a cumulative frequency diagram, it is a very critical point. You need to show the starting point, which in this case will be the beginning of the interval, right? So you also think about it in the fashion that from 57.5 to 60, we have none, right? So we get this coordinate point 60, 0. So that is what gives you the starting point. Connecting all these points. How do we connect them? That is another critical part. Should this be a curved surface or a straight line? This is connected with a straight line. Can you tell me why? So when we connect it with a straight line, we are making an assumption, and that is that the data provided here, when we say we have 13 within the interval 67.5 to 70, we'll say that this is uniformly distributed. Like in a straight line. You get the idea. Therefore, the graph should have always the terminal points which indicate the upper bound and the cumulative frequency, and these points should be connected by straight lines. So therefore, we also give it a name polygon. Now let's look into how do we calculate the medians and the quartiles from the given cumulative frequency graph. So we have already drawn the cumulative frequency graph as shown here, starting from 60, 0 and ending at 75, 80. So 80 is the total number of fish which we are talking about. Correct? So the total number is 80. This number 80 is a very critical number which we are going to use for finding the quartiles and the medians. Let us see how do we do it using the graph. So now we are in a position to estimate the frequency from the graph. To estimate the median length of the fish, we'll estimate the lower and the upper quartile, we'll find interquartile range and the 90th percentile. Well, when we say percentile, it is similar to finding median, right? So when we say median, we mean 50th percentile. When we say lower quartile and the upper quartile, we are talking about 25th percentile and 75th percentile. You get the idea, right? So, while we'll be calculating the median, lower and the upper quartiles, you will also understand, well, how do we calculate percentile? So you'll be in a position to find the 90th percentile. In all our calculations, we'll be using the given data where we already found the cumulative frequency and we do have the cumulative frequency graph. So we have a cumulative frequency graph here which shows cumulative frequency versus the upper bound. Let me write UB for upper bound. Okay. Now, all the estimates will be done based on the total number n, which is 80 in our case. We need to read the above values from the cumulative frequency graph, which we have just sketched. Let's begin with median. Median length, as I was saying, is a value at the 50th percentile. Means 50th of 80. 80 is the total number. So 80 times 0.5 will give you the 50th percentile. Value at this point, that is what we are looking into. So, what is the length of the fish, which, when the data is arranged in increasing order, is positioned at 40? Right? That is what it means. And we need to figure this out from the graph. So let's try to understand the term median. To find the median, we have to follow these steps. First, we need to find position. Position should be 50th. And then we need to find the value at 50th position. That gives you the median. So, multiplying the total number n by 50, right? So this you get 50th position is 0.5 times n. That is what 50th position is. The value at this position gives you the median. That is what median is. You get the idea, right? So, median is the value at the given position. Let me write like this. Okay. So from the graph, we'll see where is 40. So this is the position 40 for us, and we can read, drawing a horizontal line which touches, crosses this point here, and from this point, if you drop it down towards the x-axis, which gives you the value of the length of the fish. The length here was now read, and this value can be read as 68.6, and that is how you get this value, right? So I hope the concept is clear. So once you calculate this, 40 is the position for the median, then you read from the graph what is the length. That length turns out to be 68.6, and therefore the median for us is 68.6. So I hope this is absolutely clear. Now for Q1, which is the first quartile, we'll adopt the same method. We also call it lower quartile. Lower quartile Q1 is the 25th percentile. So we'll multiply by 25, 80 into 0.25 gives us 20. Now, drawing the line at 20 and then reading the value from the graph, we get Q1 as 66.6 as shown here. So that becomes the first quartile. Now let's find out the upper quartile or the third quartile, Q3, which is 75th percentile. Multiplying 80 by 0.75, it is a total number. We get 60. So now, drawing the horizontal line at 60 and then reading the value from the graph, we get the value is 70.2. So 70.2 becomes the third quartile. Correct. So that is how we find the quartiles. Now, interquartile range basically is the difference between the third quartile and the first quartile. We know both the values, and so we can find the difference now. Interquartile range will therefore be 70.2 minus 66.6. That gives you a value of 3.6 centimeters. Perfect. So that is how you find the interquartile range. Now the last part here is to estimate the 90th percentile. 90th percentile means you need to multiply 80 by 0.9. You get 72. Now at 72, read what is the value from the graph. The value turns out to be 71.8 as you can see it. So 71.8 is this 90th percentile. So that is how you need to calculate these values from the graph or read them from the graph. Now, important question is, how do we find these values from the data directly without making a graph? That is the next part we'll look into. Now here, we're again looking into the median from the given group data. I'm using the same group data which we had in our earlier example. We have already calculated the cumulative frequency as shown here. Total number n, as you know, is 80, right? So n is equals to 80. That is the total number of fish. Now, we'll define few terms moving forward. One is called median class. What is median class? Median class is the interval in which the median will lie. See, this is a group data. We are not getting the exact value, right? So what we need to do is we need to find the class or find the interval in which median will lie. So that is called the median class. So this interval in which the median lies is called the median class. Correct? Now, to find the median class, we have to divide n by 2. Dividing n by 2 will give you the value of cumulative frequency in which the median length can be found in this particular case. Now, since we are given that n is 80, so we can divide 80 by 2. Once we get 40, we're looking where the 40 will lie. So in the cumulative frequency, we find that the 40 will lie in the interval 67.5 to 70. So that becomes the median class for us. Right? So you understand what a median class is. Median class is the interval in which the median will lie. Now the second part here is to estimate the value. Right? Now we will estimate median. So that becomes the second part. We know it is the middle value. However, when the data is given to you in the grouped form, we exactly don't know what the data is. We know that all the points will lie within this interval. Correct? And therefore, what we do here is we make an assumption, and the assumption for us is that all the information is uniformly distributed within the class. That is to say, when we have a median value at 40, we're looking at the interval which happens to be from 67.5 to 70. Think like this. We say within this interval, all the information is uniformly distributed. So this is 67.5, and that point here is 70. We have 33 elements in this, right? So within this, we have 33 elements. So there are different points, correct? So we have 33 elements. And what do we need to find here? We're looking for 40th position. We know there are already 25 before this. So 40 minus 25 gives you 15. We're looking for the element which is at 15th position. That is the median. So that is a strategy for us, correct? Well, I've told you the logic, but now we are going to use two different methods. The method which I was discussing is the logic. So we'll work with the logic to find the median, and then from the logic, we'll actually derive the formula, which is kind of written here, correct? So let me explain you the formula also written here. It says that the median M is capital L plus sigma f by 2 minus the cumulative frequency divided by frequency times I, where each term, let's define L, the lower limit of the median class. That is the median class, and this value here will be L for us. Cumulative frequency. Cumulative frequency of preceding median class. So the cumulative frequency will be the cumulative frequency of the preceding interval, which is 25. We know 25 numbers are before this interval, correct? F, the frequency itself. This shows frequency 33, the numbers within the median class. We're not talking about these points, you get the idea, which are uniformly distributed. Okay, and L is the class interval. So class interval is the difference, which is 70 minus 67.5. In our case, it is 2.5. So that is how we get all the values in the formula. Once you substitute these values, you can calculate the value for the median. That's the whole idea. So let's now see how to derive this formula and then how to apply it. Now let us try to find a logic to find median. And from the logic, we'll derive a formula to calculate the median. That will help us to find the quartiles also, since quartiles are also medians of their lower half of the data and the upper half of the data. Now in this exercise, we'll always assume that all the data is uniformly distributed. When we say uniformly distributed, it really means what? When we talk about an interval, let's say we have an interval here between the 2 points, then all the data points are at same distance uniform distance. That is how they are distributed. That's the whole idea. Right. Now, when we're talking about median, median is the middle value. So median basically means the mid term, right? So when we say mid term, that gives us the position of the median. So midterm here will be total number of terms divided by 2. In our case, we have 80 total divided by 2 is 40. So when we say median, we are looking for the value at midterm. In this case, 40th term. That is what we are interested in. Now, how do we figure this out? Well, from cumulative frequency, we find that the 40th term should be in the interval 67.5 to 70. Correct? So the 40th term lies in this particular interval. Now, this interval is called the median class. We know for sure its value will be greater than equal to 67.5 but less than 70. So we know an interval within which the value for the median will be. Is that clear to you? Right? Now, since we are assuming that it is uniformly distributed, we can actually find the rate at which the value increases within the interval and estimate accurately, right? Fairly accurately. That is what the whole idea is. Now, within the interval, the value could vary from 67.5 to 70. So that is the variation. We are calling I is 2.5. So the interval length is 67.5 minus 70. I should have written the other way. This interval is 2.5. Basically, it is 70 minus 67.5, which gives you 2.5. Correct? Now, within this interval of 2.5, 33 elements are existing. So that is that 33 number. That is the frequency. So within this interval, we have 33 points. We need to find which one is representing the 40th position. Correct? That is the whole idea. So 40th means before that we already have 25. So there are 25 fish whose length is less than 67.5. So when we take away 25 from 40, we get 15. So within this interval, we are looking for 15th element from 67.5 in the model class. That is going to give us the median length, right? Since 25 elements are in the class preceding it, right? So that is the whole concept. So now, how do we find the length or estimate the length which represents the median? Well, in this case, we have seen that it could be a value which is between 67.5 and 70. That gives us an interval of 2.5. Within this interval, we have 33 elements. Dividing that gives us the gradient for finding the value. That is the increment from 67.5, correct? So the incremental value of the 15th element will be 2.5 divided by 33 times 15, which is 1.136. Adding 1.136 to 67.5, the lower bound, we get the estimated length for the median. Perfect. When you add that, you get our solution, and that is the median is 68.63. Correct? That is how you find it. You will notice that this length is similar to what we have found earlier using the graph. In the graph, we found the median to be 68.6, as you can see from the graph. There also, we assumed a uniform distribution, the straight line, which helps us to find fairly accurately from the graph the value for the median, right? So that is how you could connect it. Perfect. So once again, we know that the middle value is on the position number 40. Now this position 40 lies in the modal median class 67.5 to 70. That is the cumulative frequency of 58. Now within this interval, we have 33 elements. We are interested in finding the overall 40th position, but within the interval, it is 40 minus 25, 15th position in the interval. Assuming a uniform distribution, we find the rate at which the value is increasing. The rate is 2.5 divided by 33. Multiplying this by 15, we get the exact value, which is 1.136. That is 67 added to 1.136 gives you 68.63, and that is the median we're looking for. Is that clear to you? Now that helps us to also find a formula. All this logic tells us something, that this value, 67.5, is the limit, lower bound of the median class, right? So it has to be more than that. So that is the value of L. Okay. Now within this, we're looking for half position, which is sigma f over 2. That gives you 40 minus the cumulative frequency of the previous one, correct? So let me color it in a different way. Okay, that becomes the cumulative frequency of the preceding class. Those many we already have. Divided by the frequency within the class, which is 33 for us, multiplying it by the interval, that gives us the gradient. Perfect. And then you could substitute the values as shown here, 67.5 being the L value, 40 minus 25 over 33 times 2.5 gives us the answer, 68.63. But here, important thing is, now we have a formula to work with. You also realize that quartiles are also medians, and therefore we can similarly find the value for each quartile. Let's do it now. So we have derived a formula for the median, and the formula is L plus sigma f over 2 minus cumulative frequency of the preceding interval divided by the frequency of number of items within the median class times the interval of each group. Now, so that becomes the formula. This, we understand, is the formula for median, right? So even if we have a lower data, lower group, where we find Q1 basically is the median of the lower group, correct? So, which gives the 25th percentile, right? So what we will do now is find the position which is at 25th percentile. So dividing the total number by 4 gives us a position of 20. Where does this 20 lie? Well, clearly, 25 is less than 67.5. That means the length will be between 65 to 67.5. So that becomes the class of our interest to find the first quartile. Here, the lower limit is 65. So within the formula, we can use 65 as the lower limit. Now, since 20 is the total number, and before that we have 10, so 20 minus 10 is what we are looking for. We are looking for the 10th item out of those 15 available here. So, multiplying by the gradient, which is I, 2.5, we get the value 66.67. You get the idea, right? So that is how we could actually modify this formula to apply for Q1 and also for Q3, correct? So for Q1, the only thing is we have to divide by 4. And for Q3, we have to divide by 3/4. That is it. So the same formula can work for us to calculate Q1 and Q3. Let's once again see. How do we find the third quartile? We'll apply the same method which we did for the first quartile. Third quartile really means we are looking for 75th percentile. So 3 over 4 of the total number of elements will give us the position of 60. Now 60 will lie where? Well, 60 lies within the highlighted group 70 to 72.5. There are 19 total elements in this. So this number 19 comes in the denominator and 2.5 is the interval. So that gives you the gradient, right? Now within this, we are starting from the minimum value, which is 70, and therefore L value is 70 for us. Now it is slightly more than 70. How much more is what we are trying to calculate? That is given by 60 minus 58. 58 is the cumulative frequency of the preceding interval. And therefore, once you calculate this, you get the answer 70.26. And that is how you calculate it. You can again check the values with the previously got. So that was 70.2. Fairly accurate, right? So from the graph also, we got a very accurate value. Now in this particular case, we see that the length of quartile Q3 is 70.26. Now what is interquartile range? Interquartile range is the difference between third quartile and the first quartile. Taking the difference, we get 3.56 as our answer. I hope with this you understand how a formula for the median is derived, also how it can be applied to find the quartiles. So these are very critical steps to understand. I hope all these concepts are absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.